Okay, in this video we're going to have a look at the area of rectangles and triangles. So to start off with, we're just going to go with a fundamental area, which is by using squares and counting squares. So in this rectangle here for number 1, the area is how much space there is inside, how many squares you can fit in inside. So if I count them, I get 1, 2, 3, 4, 5, 6, 7. Then another 1, 2, 3, 4, 5, 6, 7. So that's 14. Then another 1, 2, 3, 4, 5, 6, 7. That's 21. So we have 3 rows of 7. Or 3 sevens. Alternatively, you could think about it that we have 7 columns that each have 3. Again, the quickest way of doing 7 lots of 3 is 7 times 3. So, if we had dimensions now put on, so we actually say what the lengths are, so 7 and 3, and let's say these were centimetres in width, so 3 centimetres in width and 7 centimetres in width. So the area is going to be 3 rows of 7, so 3 lots of 7, which is 21. That's where our 21 came from. Remember, we had 3 rows of 7, but that 21 means that we had 21 little squares inside this shape. And our squares are going to be centimetre in length, so we call them centimetres squared, or square centimetres. So for a rectangle, to find the area, we multiply the dimensions together. So depending on the words that you learn, you could have length and width. You could have base and height. Okay, some people go with length and breadth. So there's lots of different languages and words that we can use for it, but it's still the 2 dimensions multiplied together. Okay, in the next example, I'm not going to draw this to scale. So whereas it looks like this is going to be 4 and that this is going to be 5, I'm going to just put different numbers on it because now we know the theory behind it. We can use this diagram to represent whatever rectangle I want. So let's call this one 6. Again, 6 meters, and this one here 11 meters. Well, 6 meters by 11 meters is going to be an area we're going to have 11 rows of 6 or 6 rows of 11. Either way, we either have 11 sixes or 6 11s, which will give us the same answer, so 66. But in this case, the squares were going to be meters wide. Meters wide, so we're going to write square meters, or meters squared. Okay, then we move on to triangles. So triangles, slightly different, because we don't have full rows. If we had, again, let's go with this 1, 2, 3, and this 1, 2, 3, 4, 5, 6. So let's go with a 3 by 6 this time. If we stuck with the same idea as before, area is length times breadth, base times height, that would suggest that we have 3 rows of 6 squares. Well, we don't. If I split them into rows, I haven't got 6 full squares in any of them. The closest I've got here, where I've got 1, 2, 3, 4, those 2 may combine to give 5. Then I've got 1, 2, and those 2 may combine to give 3, so that's 5 and 3 is 8. And then maybe these 2 combine to give me a 1 whole, so that gives me 9. Not 18 if I just multiplied those together. If I multiply these together, what I actually find is the area of the rectangle that has 3 rows of 6. And hopefully you can see, because this goes from diagonal to form the triangle, we end up with 2 lots of this triangle. We only want 1 lot of the triangle, so we need to halve our answer. So if we do 3 times 6 gives us 18, that's the area of this whole thing, and then we need to halve it to find the area that we want. So the area in this case is going to be the base times the height, so 6 multiplied by 3, and then we're going to divide that by 2. Now, you can write that as divide by 2, or if you want to be a little bit nicer with it, 6 multiplied by 3, and write the division as a fraction, all over 2. Either way, 6 times 3 is 18, 6 times 3 is 18, and then divide that by 2 to give us 9. And if I put units on there, let's say that was millimetres this time, then it would be square millimetres fitting in. Now, on number 4, slightly different shape here. When we were in number 3, this angle in the corner was a right angle. These two lines are what we call perpendicular to each other. And the perpendicular distances gave us the height and the width. Now in this shape, the bit along the bottom isn't perpendicular to the one that we've got. So it comes out at an angle, and this one comes out at an angle as well. So the perpendicular height is actually this one here, that goes from the very bottom to the very top. You can see, if we're counting rows, it's 1, 2, 3, 4 full rows. But again, we don't have to worry about it being exact. We can just write it as anything. As long as we know now that we're going to multiply the dimensions together and then halve our answer, that's what's going to help us. We just need to make sure that we don't fall into the trap of using one of these slanty sides. It has to be this perfectly vertical height, the one that is perpendicular to the base. So let's say this one here is 7 meters. Let's call this slanty length 5 meters, and let's give this vertical height of 4 meters. Now the 5 meters on this slant is just there as a decoy to make sure you know what you're doing. In order to work out the area, we're going to have 4 rows of 7. Okay, 4 rows of 7 will give us this rectangle. Okay, so it's not quite the same as the last one, but if I cut this bit off this side and I stuck it over here, then I end up with this triangle here, which is exactly the same size as this one that I'm trying to work out. So the area will be twice the size again. So the area is going to be the 2 dimensions that multiply together. Ignoring this 5 altogether, I just want the one that comes across and the one that is a right angle to it. So I get 7 times 4 divided by 2, or if you'd rather, the nicer way, a better way of writing it is 7 times 4 and writing the division as a fraction. And that gives us 7 times 4 is 28. So 7 times 4 is 28 in either of them, and then halve that to give us 14. And our units are going to be meters, and we're counting the squares that are made by those. So meters squared.